Rapid urbanization in many large cities, which serves at the center of development in economy and society of the countries, can lead to many severe environment problems. Bangkok, the capital city of Thailand, is also facing many environmental problems. One of which is the deterioration of water qualities in natural waterways, such as canals from the discharge of wastewater from the human activities without appropriate treatment. With an increasing wastewater quantity generated from the people, together with constraints on shortage of land and substantial increase in land price, land acquisition for the construction of new large-scale wastewater treatment facilities becomes more difficult. One alternative solution to this problem is the retrofitting and upgrading of existing wastewater treatment plants to increase their treatment capacity to cope with the increasing wastewater quantity generated.
ในเมืองหลวงเนี่ยประชาชนอยู่กันหนาแน่นมากเพราะฉะนั้นมลภาวะในเรื่องของน้ำเสียเนี่ยจะมีปริมาณน้ำเสียมากและสิ่งที่มากับน้ำเสียก็คือขยะนี่ก็เป็นปัญหาหนึ่งของกทมที่จะต้องแก้ไขเพราะว่าน้ำเสียกับขยะเนี่ยจะรวมมาด้วยกันเพราะว่าประชาชนเนี่ยยังไม่ทราบเกี่ยวกับเรื่องผลเสียหายของการทิ้งขยะลงในท่อระบายน้ำเพราะนั้นมันก็เป็นปัญหาเกี่ยวกับเรื่องของการบำบัดน้ำเสียด้วยในเรื่องของขยะ
In this aspect, the improvement of treatment capacity of existing central wastewater treatment plants in Bangkok would require new technology with higher treatment efficiency and smaller footprint so that they can be constructed in the available land area of existing wastewater treatment plants.
From the cooperation between Kasetsart University, Department of Drainage and Sewerage, Bangkok Metropolitan Administration, and Mitsubishi Rayon Company from Japan, which foresee the needs for development of new wastewater treatment technology to solve water pollution in Bangkok. In parallel, direct application of membrane for filtration of treated water from existing wastewater treatment plant of Bangkok Metropolitan Administration for immediate reuse is also under study.
The MBR wastewater treatment system had the functions of biological treatment and sublimation of sludge from treated water in one treatment unit. The use of MBR has several advantages over conventional treatment, such as 1. The system could receive larger wastewater flow and cope with fluctuation of wastewater quantity and characteristics. This is because the MBR can maintain higher biomass in the treatment tank without depending on sludge setability like in conventional system. 2. Less installation space would be required when compared to other conventional treatment systems, as the system combines biological treatment and sludge separation in one treatment unit.
For space saving, MBR has two functions in reducing the footprint. Conventional way requires a large aeration tank where there is a limitation to keep microorganisms concentration. By applying the MBR process, we can keep the higher microorganism concentration using the membrane separation to achieve compact aeration tank. Secondly, conventional way requires large sedimentation tank to separate the microorganisms by gravity. Whereas through the MBR process, microorganisms can be removed by using the membrane instead by eliminating the sedimentation tank. Based on these two functions, we can reduce the 50 to 80% space using MBR to treat various wastewater in comparison with the conventional activated sludge process.
3. Excellent treated water qualities could be obtained as some paint solids were completely removed during the filtration of water through membranes with small pore size. Direct reuse of treated water is possible without any need of further treatment.
In regard of the biological process, microorganisms including the bacteria works to treat contaminants such as organic substances and nitrogen. Subsequently, microorganisms must be removed by solid-liquid separation method. Membrane has smaller pore size in comparison to the microorganisms, so microorganisms can be completely separated when clear water is passed through membrane pore as a high quality of treated water for water reclamation.
Prior to the treatments of wastewater using MBR, less floating objects and debris are removed from wastewater by screen with 10 mm and 5 mm opening to prevent the clogging and possible damage to the pond. It includes the removal of gravel, grit, and sand that come with the wastewater during its collection through wastewater drainage pipes. Thereafter, the wastewater is pumped into the aeration tank where two treatment steps were carried out. The biological treatment used anaerobic microorganisms to degrade organic pollutants in the wastewater, after which physical separation of biological sludge and treated water was performed using 0.4 micrometer pore size membrane filtration. The microorganisms are retained in the biological reactor, whereby the biomass concentrations are maintained 2-3 times higher than that in conventional wastewater treatment system. The treated water can be reused in several purposes, such as watering the plant, cleaning the floor and equipment, and toilet flushing in the buildings.
ในระบบการทดลองของมหาวิทยาลัยเกษตรศาสตร์ที่เข้ามาทดลองเกี่ยวกับระบบการนำน้ำรียูสมาใช้ประโยชน์เนี่ยซึ่งก็มีผู้เชี่ยวชาญจากประเทศญี่ปุ่นหรือว่าวิศวกรจากประเทศญี่ปุ่นมาควบคุมดูแลด้วยคุณภาพน้ำเนี่ยดีขึ้นนะฮะเนื่องจากมีระบบเมมเบรนเข้ามาเกี่ยวข้อง
The wastewater system is controlled by Programmable Logic Controller or PLC for efficient control and adjustments of operating instruments and continuous monitoring of the system during the plant operation.
Now, more than 4,000 MBR plants using Mitsubishi membrane have been operated in the world. I strongly believe it is time to apply and expand this MBR technology to Southeast Asian region to protect water environment and to produce the water resources.
The wastewater treatment system can be considered an innovation that will bring back clean water for us to use and restore our environment back to its original form.